So can you see the graph? So this is one of the traveling salesman problem. So we have 1, 2, 3, 4, 5, 6 customers, which means uh, how many combinations of the candidate solutions that we can find. Any of you have idea? So this numbers is the cost. So if I want to go the initial, like for example, the depot is from the A, go back to the A, then what is the minimized route I can took from A to A? So in the traveling salesman problems, we can find the solution by having this blind search, the exhaustive search, the brute force. So that's three have the same meaning, which means I will try to find all the combination, calculate the solutions, and I will do the ranking. So I choose the one who have the least cost. So how can we know how many combinations? It's basically n minus 1 factorial. So you have 6, so that's the n. You have the 6 customers here, so you have the 6 points. It's minus 1 because you decide on the first, and that will be the same for the initial spot, right? But if you don't decide on the first, that means you can try to start in any customer. So I can start from B, I can start from D, from C. That means more combinations. So you don't need the minus 1. So you have this n factorial. So, right, so just make it smaller. So we have this n minus 1 factorial. If I have 6, that means 6 minus 1. So 5 factorial. 5 factorial is 5 times 4 times 3 times 2, right? So that is already quite a lot. So just compare when we have it 4. So we have 4 meaning 3 factorial, 3 times 2, that meaning 6. But having 6 combination, that is already little one, just a few. But we have this A to C is similar to C to A. So the direction having it the same cost, because there are other cases when A to C is different with C to A, right? Because it's like it's one-way road. We need to go to the other way, which is further. So the cost will be different. Because the cost is the same, so we can divide it by 2. So n minus 1 factorial divided by 2. So we only have 3 for the 4 customers, only 3 combinations. So that is quite easy. But just add it 1. So we have a 5. So that means 4 factorial. So that is 24 divided by 2 is 12. Oh, so from 3 to 12, that is already significantly increasing the number of combination, right? So having it 3 compared to only, let me just try 1. That is not a big gap, but 1 comparing to 12 combination, that is already a big gap. And for this case, it looks like a simple one, right? It looks like still a simple graph because we have a real world problems that if you cover East Java, for example, the delivery pickup cases, then you have more complex graph compared to this one. So having only 6 customer, of course, the company expect to have like 100 more customers. So that's make it more complex. So having the 6, you already have 5 factorial. So 5 times 4, 20 times 3, 60, right? Times 2, 120. So it's already very high in the terms of number of combinations. So it's already more than 100. Will we try to calculate this 100? Manually, no, but you still can ask the computer to help you to do that. So just run your code, ask the computer to do it, for them to finding the 100, perhaps 1 minute, just a few seconds, right? So they are quicker than us. So you still can do these optimal solutions. But yeah, the real world, if you already have 100 customers, then this is not feasible anymore. So the time not allow you to do the calculations. Time to run is also a cost. So what we do is that we have this approximation. So rather than finding all the combinations, I just do approximation. So go back to that terms nearest neighbor. So you have this k nearest neighbor. That means k class. So you find the optimal class in your data. But the other nearest neighbor in the prescriptive is that you find the neighbor which are the closest. So if you start from A, that means, okay, A can go to C, E, F, D, B. So it's connect to all of the customers. So which one is the closest one? So based on the cost. So we have this 29, 13, 24, 22, 12. So 12 is the closest one. So we choose A to B. So that's the meaning of the nearest neighbor. And you can continue having this rule until it's go back again to the A. So A to B because it's 12. And then from B, we already have 3 there. I think 3 is the least one. So from B to D, and then you continue until it visits all the cities or the customers. Go back to the A. So you just have this one route, right? With the least path. So this is what we call approximation algorithm. So you try to solve the problem by having the approximate intuition rather than you try all the combination. So that is nearest neighbor in the prescriptive. So we have this to nearest neighbor as well. Other thing, so the interesting part of the optimization field is that how you solve the problem is really based on your experience, judgment, intuition, right? So that's the intuitions to how can I solve this? Okay, then I will find the closest one, the least one. So that is the first intuition. But there are a lot of other intuition. It's based on your experience. So if you have a tendency to solve your problem step by steps, nearest neighbor is that one. So you solve it step by step. So you only focus on the next part, right? So you focus on A, only focus on A, and then okay, after A, what will I do? So that is you solving step by steps. So it's like you have a big problem, and then you divide it into a smaller problem, and then you solve it one by one. We call this partial solution. So we try to develop a full solution from the partial solutions. So you do it zoom in. So you focus on the small part. But there are other intuition as well, right? So how we can solve this? I already take a look at all the costs, and it really bothers me because the smallest one is 3, but the highest one is 29. So wow, that's a biggest gap. That's a really big gap. And I don't want to go this 29. That is a really big cost. So I don't want A to the C. So I will avoid that. But we can go this B to D. We can go this E to D or D to E because there are 3 and 4. That is a small one, F to D, D to F. So when you see the problem that way, it means you do the zoom out. So you see the problem as a full problem, not one by one. So that is what we call cheapest link algorithms or the minimum satisfiability, which means I see all, and then I will group the problem into two connections. So this is the group having the small cost. This is the group having the biggest cost. So I try to avoid the biggest cost. Let's let's have the solution from this small path. So we have B, D, D, E. So I think that is a good one. B, D, E. Okay, so I already formed this solution. And then we can continue until it starts from A back to E, go back to A again. But we already have this BDE or BDF as a part of the solutions. So yeah, if you have a tendency to solve your problem like by zooming out, so you see, you consider everything in that, and you start from this full solution. So we have that intuition implemented in the approximation algorithm as well. So that is the interesting part. There are a lot of method to do the approximation in solving the problem. A lot of new algorithms because it's basically from the way we solve our daily problems. So the inspirations is just from surrounding us. Even the name is very explicit, like diving, uh, B algorithms. So how B works, N algorithm. So how N finding food. So that is the problem of the N. So we try to apply this N algorithm. There is Firefly as well, Firefly algorithm. So how Firefly works or how do they meet? So they have the problems and they solve the problem by doing that. So we implement what happens surrounding us in our nature to this optimization problem. Right. So even neural network also use a lot in terms of optimization. So not only for prediction, but also for optimization as well. So this is more like a general method to solve all kind of problem that is in data analytics. Right, so you have this, right, ARIMA, exponential smoothing, and then you will have KNN next, regression as well next. There is demand sensing, but we will not talk about that. And there is AI here. So basically, neural network is part of the machine learning. Machine learning is also AI. So that is the terms that we will use quite a lot in terms of artificial intelligence, machine learning, and artificial neural networks. So these three have a close connection. Right, so let's see the statistical analysis. Where is the neural networks here? Right, so it have the 6 most used algorithm together with the statistics. In terms of data analytics, the field is data science. Yeah, we use the neural networks also quite a lot. If we see number 1 here is regression. So you also learn about regression in the data analytic class. So yeah, we have these regressions to find the relationship between variables in your data. And we also can use regression for doing the predictive as well. And then clustering. So yeah, the clustering and the regression here are in the top numbers. You will learn about decision tree there and the k nearest neighbor. Random forest is basically multiple decision trees. So if you have more than one decision trees, we call them random forest. And then you have the support vector machines. Uh, I asked Gerald to also add one more if the time allowed, the support vector machine, but let's see. So you already have three data mining methods. So if we can learn about support vector machine, then that will be great. And naive Bayes. So you have naive Bayes also to do the classifications. So we have neural networks here, the regular one, and there is a deep learning. So that is the recent development in the neural networks. So this is the hype from the AI to the machine learning to the neural net, and then now is deep learning. So that's just beginning in the millennial year, right? So in the 2004, we are very uh, thrilled to welcome this AI concept. And then we have this machine learning in 2009. Around 2014 is all about neural net. And nowadays it's all about deep learning because I think around those time we have all social media appearing, Facebook, I think before Facebook, there's Friendster and Instagram. Yeah, there are a lot of social media after that. So Google, even the translations. I I still remember when I was in your age, uh, the Google Translate is not really that good because the data is still few. But now because the data, they have already gathered a lot of data, then we have this quite uh, big informations and they can give you a summary. That's why now people call them everything using AI. So that is already starting in the 2004. But at that time, the information or the data is still limited. But now, having all this data, you can easily find the meaning of everything. So if you have a question, you can just ask, for example, the chat GPT, or you can just Google it. Google nowadays is different with like 20 years ago. So now they always give you the summary on the top, right? But before, we still confuse which link that I need to open. So which link will answer my questions. But now you can just type in your questions in detail and then they give you exactly the answer that you need because they have more data about it. So that's the era of deep learning. Right, so we have this classification of forecasting. You already have this time series methods. So basically we are in this objective forecasting method. Subjective, we don't go this one. This is like a judgmental forecasting based on the judgment. So very subjective. We have this prophecy as well, educated guessing, but the profit model that I think after the midterm, Gerard will introduce you. That is the one from Facebook. The profit model is part of the objective forecasting methods because it's more into the decomposition patterns. So it's divide your pattern into trend, seasonal, right, and other trend, other patterns. So that is how you decompose your data pattern, and then make sure that all of this pattern is included as an input to do the forecast. So even in the profit model, there are additional one that they consider. We never considered this before, which is the um, national holiday. So every year, so this is part of the seasonal, right? So we have this national holiday, we have weekend, we have weekday. So having that information, so having this time information in our time series method, they are also useful uh, because we know that this time the sales will be increasing. For example, at the end of the day, oh, this is Christmas. This is a new year. This is Idul Fitri. So we know that the increasing demand will rise there. So uh, that is also considered in the profit model. Previously, we only based on the previous data, right, or historical part, but we don't really care about what event or holiday in those future times. So having these informations also good as an input. Right, so we have this neural networks. So a neural network is in both the time series and the causal. So they say the advantage of the neural network is that because of they can approximate both linear and non-linear. So not only time series and causal, but because they can handle linear and non-linear pattern. So you know the linear is the one that having straight line, the nonlinear, including the exponential, right? That's exponential pattern of trend or of the seasonal. Neural network also good on those things. Right. So we have this modeling flexibility. So we have input, process, outputs. How many variables in the input, how many nodes in the process, how many variables in the output. So for example, here, uh, deciding or predicting whether the customer can we give them credit or not, or can they fulfill the payment of the credit or not, right? So the decision will be giving them credit, yes or no, 0 or 1. Okay, so let's see what makes we can find out the decision here. Uh, okay, they put gender here, 0 and 1. So the other one is income. Yeah, so I think that makes sense. I'm not sure about the gender, but income, uh, that is the factor. The age, yeah. So uh, they have these three variables to decide on the credit. So three input, they have the last node is as the output, and in the process, they have 1, 2, 3, 4 nodes. So in this layer or the network architecture, what we need to find is the optimal number of these nodes. We call it hidden nodes. So we have this input layer, hidden layer, output layer. So this is one hidden layer. So a single hidden layer with 4 hidden nodes. If we have it, so this is the categorical data. If we have in the time series data, so we want to predict the sales in June. So we have the sales in May, sales in April, marketing as well in May. So the previous history data to decide the sales in the future. So we have 3 inputs, 1 output of numerical cells, and this is also for hidden nodes. Is it possible as well to add more hidden layers? Yes, that's possible. So this is one hidden layer, right? Single hidden layer. If you have more than one, that's what we call deep learning. So when we need to use deep learning, if you need to use more than one single hidden layer in your neural network architecture. So I can add one more hidden layer or even more. So having it two, three hidden layers and having it different in terms of number of hidden nodes. So for example, the first hidden layer is four hidden nodes. The second hidden layers is five hidden nodes. So we can do that as well. So that is the challenge. We need to find the best model with the optimal number of uh, hidden layer and hidden nodes. If you use more than one hidden layers, every layers their have their role. So, for example, in this um, 3D three-dimensional data sets, so you have if you do kind of animation or a picture, so you have the face. From the face, if you have the eye, you have the nose, you have the mouth. So one hidden layer for the eyes, one hidden layer for the nose, one hidden layer for the mouth. So every hidden layer have a certain roles to learn from a specific data. So basically, you group your data. So that is why we call it deep learning because you learn it deeper. So you put them into groups of smaller data and you learn every part of them. So we call it artificial. So we don't call it only neural networks. If we call it neural networks, that is the same with these medical terms. So neural, right? From the neural. So we have these neurons in our body in the humans. Networks means the connection between neurons. So that's what we call neural networks. But in terms of computer science, we add artificial, right? So it's not only an N, but ANN, the artificial neural neuron in our human nervous system into the computer. So the idea is from our own body, and we ask the computer to solve the problem uh, by imitating this how the human brain work. So that's uh, why we call it artificial neural network because we make neural network that is artificial in the computer. Right. So we have um, some of these descriptions, but this is more into medical terms, right? So we have this neuron cell, nucleus, dendrites, axon, synapses, which give you response in learning. The role of each of the parts and how the neuron system works. So basically, we imitate them and we try to implement them to solve the problems in the data set. So we have a large data set, which means this is all the um, all the things, the inputs, right, that come to our body, and then how we respond. So giving an output response, in this case, because it's a predictive, then the output will be the prediction, is based on analyzing all of this input. Right, so let's see this one. We have input, process output. So we have these three inputs and we have the weight as well. Sorry, until n here, yeah, three plus n numbers. So you have not only the number of the input, but you have the weight of it because, like for example, in the previous case, uh, we need to predict on June. So I have the data of May and April. Do I will put the weight the same or I will put May is more weight. That means what happened in the recent will have the higher possibility to repeat again in the future. So you put a different weight. So that's in the process is the summation of having the weight times the input. So um, the weights here, it can be adaptive or it can be not adaptive. So you can adjust the weights or you don't adjust the weights. But basically in the neural networks, after it go to the output, and then it will give you feedback, right? So it's what we call back propagation. So it's back prop. So you do this feed forward learning. That is the term. Feed forward. So you do the learning. First, you have the data. You have the desired output. If you have the desired output, or if you not, then you only learn from the input. So you do this learning forward. But then you have the results, right? The predictions. You predict the past, and you try to compare with the real one in the past. Oh, if it's really big gap, the error is still big, right? So if the error is big, then you add this information of the error, go back into the learning process. So this is what we call back propagations. So feed forward learning and then back propagation. So we have this the architecture of the neural sometimes people call it multi-layer, right? But multi-layer have two meaning. So is it multi-hidden layer or this multi-layer, which means input, hidden, output. So this is already multi-layer, right? So there are three layers, but the hidden layer is single. So we need to be careful of that. If we state I'm using multi-layer, what does that mean with the multi-layer? Is it multi-layer single hidden layer or multi-layer multiple hidden layer? So what is the multiple one? Is it all the layers or the only the hidden? Uh, Usually, in the past, in the past, uh, in the beginning of artificial neural networks, they say this multi-layer means this one, the standard one. So you have input, hidden, and output. So your single hidden layer, that's already multi-layer neural networks. So if you read um, papers since in the beginning of artificial neural network, that is people using this term. But starting the time when deep learning appear, we have make it possible, right? Because now the cost of handling a big data is cheaper than in the past. So you can have this multiple hidden layer. So nowadays, people will suspect if you say multi-layer, that means multiple hidden layer because now we are in the era of deep learning. So that is important to make sure that you have the similar uh, meaning of using the term. So I think it's better to say multi-hidden layer, right? Or multi-layer, meanings it have input, hidden, and output. A multi-layer with a single hidden layer. Um, right. So this is what I call what happened in our body in the nervous systems. We try to imitate them into this neural network architecture. So you have this input, the weight, and then you have the activation element here as the process, and here is the output. So the architectures is based on the layers and the connections. So it can have all the connection or not. And in terms of processing, the rules, so how your inputs are processed, is it using that times the weight, you do the summations, that is the standard one, or you use other rules of processing, right? And yeah, that includes the learning rule. So how your weights will be adjusted. So for example, in the backprop, after you get the error, okay, this error will be the input again. So I adjust the weight. Right, so this is what I mean. So people call it multi-layer feed forward. So this is the the rows, the arrow is go forward, and this is multi-layer, which means input, hidden, and output. But we also have this two-layer feed forwards, which means you only have input and output, or this is usually the hidden layer. So there is two hidden layer here. Uh, there is input, the first hidden layer, second hidden layer, and there is output. Or we can have a single layer. They all go back to those nodes. The common one is having this multi-layer feed forward. There are two kind of learning. So this is why artificial network is also one of the machine learning, because basically we use them to learn from the data. How we learn, there are two types. Is it supervised or unsupervised? So supervised is like we learn to read. So you already know your output. So that is supervised, which means uh, you have someone or something to supervise you, which is the output. So you already have your targets. I know my outputs, and now I try to pairs this input and output. So the network will be adjusted associated with this matching input and output. So that is supervised learning. So this is like classification data sets. You have you already have historical data. So uh, if it's male and the income is like this, and then the age is this, then we give them credit. So you know the historical data. You already know the decision in the past, right? But we try to develop a model that when we have a new input, then it can suggest you what will be the output based on the couple of input and output in the past. That will be different if it's unsupervised, because in unsupervised, only inputs supplied, which means you don't know the output. So the network will determine the categories of the inputs. So we call it a self-organization. It's like understanding speech. So we don't know the output. What you can do is that you try to uh, find the categories of the input. Right. The backprop neural networks, we have this. Is it this? Oh, this is just one of example of the architecture. You can have the total number of layers will be 3 or 4. That means you have 1 or 2 hidden layer. It's fully connected. You do it feed forward. This sum of the products. You have this activation function sigmoid. This is the standard one. That will give you the input times the weights, and you do the summation. And yeah, the learning is the supervised backdrop of error. So you have the error feedback after you go feed forward into the output, right? So you learn from this error backdrop into the input of the learning. There are Hebbian learning as well. So in terms of activation function, so the learning one, there are several of them. I'm not sure if perhaps we can find it in here as well. But sigmoid is the common one, Hebbian, and there are others. The concept, uh, like the mathematical formula that we use, we call it gradient descent. So if you find the GitHub of the neural network model, you always can find this part where they implement this gradient descent because that is how they do the learning. So you adjust the weight in your hidden layers. Um, yeah, so I think this is for general. So you decide your training and testing set. Uh, how many percent training, how many percent testing, and then what you do is you have your input, it's do learning, generate output, and then you compare your desired output, which means this is the supervised learning. You compute the error, and then you back propagate the error to adjust the weights. And then you repeat this process on every pair of input output or every event, every data. And then you can repeat for the entire training sets. So for example, okay, this is the apple is uh, 10, so you will repeat it 10 times. The network designs, yeah, you have the number of layers, number of neurons in each layer, and what are the activation function. Right, so yeah, this is what we need to pay attention as well. So in terms of neural networks, we tend to normalize the data because if we have more than one input, we have multiple input, right? And they have different range of data. So for example, age is like 0 to 100, and then the income is like 1 million to 100 million. So that is a big gap of uh, the range of the data. That's why we need them to be in the same range. So we normalize the data. We can put it into all 0 to 1. Does that make sense? Because you have multiple inputs and they have different range. Sometimes the range is quite big. So how we can process this having is different in range. So what we do is we normalize all the data inputs. Right, and you can also do the uh, optimization for the learning rate and momentum. So this is two main parameter of neural networks. So you can decide on how much is the learning rate. Is it will learning quickly or just learning it slowly? And basically, that will be the different direction with the momentum. So both also between 0 to 1. So you can have it low learning rate, high momentum, or there are already a lot of study about this. So you can also use what the scholars find, what is the best learning rate and what is the best momentum, or you can find in your problem what is the best learning rate and momentum. So this is like a hyperparameter in your model. And then be careful with overtraining. So basically in the artificial neural network, when they ask you, is it having a good performance in your neural networks, then what they mean is they will ask whether you do overtraining or under training. Uh, because you have your data also divided into training and testing. So whether you put too many data in your training, so that's what makes it overtraining. And other part is to be careful, get stuck in the local minima. Right. We have yeah. So artificial network can handle all of the data patterns. So it's the same with the ARIMA. So trend, seasonal, cyclics, uh, the linear, the nonlinear. The ANN can handle that well because it's basically can learn from any types of data. This is the activation functions. We have nonlinear threshold sigmoid. Uh, so yeah, so this is the sigmoid function. It's like an S as a sigmoid. This is a sine function. This is a step functions. The common one is the sigmoid one. We have binary bipolar linear sigmoid as well. So in terms of activation function or here the transfer function, there are several types. So if you try to use the neural networks in tools like Python, MATLAB also have that. So in the past, what we study, we always use MATLAB for the data analytics. So the WEKA also have that as well. So we can just directly choose what is the activation function. And then, yeah, the application of the artificial neural networks is broad. So it's not only for forecasting, even for the optimization, you can use the artificial neural networks, the modeling of complex function, pattern recognition. So basically, all things of data analytics can use the artificial neural networks because all types of learning, even with the one with big data, artificial neural network can handle it well and quickly. Um, yeah, so right, so this is the example of the problem of the forecast. So you have 12 months value, you split the 70/30. What is the output for the next or the current month? You put it into neurons input, hidden and output 12 because it's 12 previous 12 months. That means your input is you having 12 nodes, right? 12 nodes in your input neuron. And then you have single hidden neurons. This you can try. You can try 6, 4, 8, and one output is for the current month. And you use this backprop, the learning rate is 0.5, the momentum is the same, and we do 20,000 iterations. And this is the forecasting results. We have that 70/30, right? Training and testing. So this is the training 70, this is the 30 of the testing. So this is good enough forecast. So this is a good one. How we can say good because it has seasonal, right? It has slightly in terms of trend. Yeah, it's have a trend. In the one that is having the suddenly increase, suddenly decrease. That is the that happens regularly. So that's the seasonal. And the forecast here in the pink one, it can go, even though some of them is not, but it's really close to the uh, peak. So the one that is declining, except this one in the testing. So that is common. You really do good in your training, but it's not really good in your testing. So that is the common one. But this one is already good enough. So it's try to follow the pattern. It's try to follow the pattern. Uh, I think why this one is because the pattern in your testing is different with your training. So in the training is like more having a regular pattern, but this one in the testing, it's have more up and down, right? In the middle of this season, having a lot more up and down. But overall, this is a good performance of the forecast. Mm, there is this term. So other than overtraining, undertrainings, we have this overfitting. So overfitting means that we don't um, it's not like this is too good model, no, but the performance is bad because it's overfit, or the performance can be really good, but if you give them a different input, then the performance is not that good. So that can be the case of the overfitting. So your model will perform very well in your training sets. But when you give them another different kind of sets, which is your testing, the error will be big. So that's what it means overfitting. So it's really fit into your training set, but it's not fit into your testing sets. So it's very specific into your training. So in terms of generalization, it's not that good. Generalization means any inputs of data, it will perform well, right? Um, One of the reasons is can be you put too many iterations or epoch in your when you're running your training sets. So we need to pay attention how many iteration as well. And then how many iterations, meaning the time of you. So sometimes we can give them some more time, they will find a better solution. But if you give them too many times, then they will do overfitting. So what we can do, you need to find this optimal time of training as well. So you can, people usually draw them in graph. So when it still go down, like the error of the training still go down, then you can continue the time. But when it start to go up, then that means you need to stop the training. Um, so this is what you can use, like how many data I need for the training. So this is based on the numbers of the units divided by the error. So if I have my problems in 80 units and the expected error is 10%, then the total data that I need is 800 data. Right, so even artificial neural network have advantage and disadvantage. So the advantage is that it's really good for big data, in especially data that have a lot of noise insights, easy to use. And then we call this the neural networks having this way to generate the rules, right? So we don't know what happened in our data. So we try to extract the rules from the data in terms of classifications and in terms of predictions. Neural network really good at that to extract the rules because it can adapt well into your data. But there is also disadvantage in terms of the it is a black box. We call them black box because we um we we don't know how they can extract the rules. So that's what happens. So it's really different with the decision trees. When you do classification and decision trees, you can explain how the rules is formed because you have this uh, graph of the trees of rule. But in terms of neural networks, we cannot explain how it can form the rules. Um, so one problem, another problems, um, they will, uh, we don't know how they can solve different kind of problems, right? So that is why what we can do with artificial neural network is try a lot because we don't really know how they work. That's the black box. But they are still very useful because it's easy, it's quick, it can handle all of the data set. So we don't really need to learn our data set that much. The neural network will help you to extract the rule, right? But how they can extract the rule, that's will we cannot quietly explain it. That's yeah, that's the disadvantage of the neural network. So we trust our brain. So that's kind of similar logic. So they work like our brains. So you have uh, the more you feed your brain knowledge, then you can give response by your knowledge, right? So that's but you don't really know how it works. I mean, how I can come up with this decision with solution in my brain. So that is what happened with artificial network as well. Right. So this is the end, the summary. Uh, yeah, why we still use a lot of artificial neural network nowadays because of their excellent results, and we don't need judgments or we don't really need to learn deeply about the data. The neural network will give you knowledge about that. So because they can generalize the knowledge. But in the other thing, they cannot extract the underlying model. So how they can extract the knowledge, that means the model, they cannot do that. But we what we can do is that finding the best architecture to solve that problem. So like how many hidden layers, how many hidden neurons, what is the activation functions, what is the learning methods. So that's uh, what we can do to optimize. And the other things that we need to consider is that it's computationally intensive. So even though there are freeware server available now, MATLAB is not open to public, right? So you need to have the license, but now you have more options in terms of applying these neural networks. But still, if your problem is not that complex, so you don't have that big data, for example, then it's still worth it to use that moving average, for example, or single exponential smoothing. So go back to the aim of the forecasting. It's not always the one who have the lowest error by having a more complex method, but the one who fulfill the needs. So if the data is just still not that high, it's just having a stationary data, it's not non-stationary data, then I think you don't need to complicate it yourself by having the neural networks. The data is stationary. Neural network is more into the non-linear, non-stationary, the more complex data that you cannot extract the pattern yourself. There are a lot of noisy inside, right? But if your data is stationary, it's really obvious about the pattern of about the pattern of the data, then moving average. So the standard statistical forecasting methods is already good. Uh, that is why still neural network is in the part of the computationally intensive, especially the deep learning. So even in the neural networks, do not always go to the deep learning. If your case or your problem do not need to use the deep learning, then don't. That's always be the case when you have your thesis. So why you need to use a complex model like deep learning when you can solve it just with a single hidden layer? Okay. Any questions? Right. So I think that is all for today. We have we have I'm not sure what is the due date of the artificial neural networks assignment. So perhaps Gerald give you, if not today, is tomorrow, right? But tomorrow is a national holiday. So this week you have 1 week for your artificial neural network assignment. And yeah, so that is the theoretical insights into the artificial neural networks. And I think this method still have more development in the future because it's like a main part of the AI. So um, you can start implement it by doing the prediction, and then next you can also applying it for the optimization. So yeah, if you have any difficulties in the hands-on in ARIMA and neural networks, please let me know. So perhaps Gerard will also discuss the results with you, the result of the assignment. But if you think you need more discussion about that, then we can have time for that in my session. So we can talk more about that in my session as well. Before we stop this forecasting, and we will go to the prediction, right? So for the non-time series data, will go there, having focus on the data mining part. All right. Thank you all for today. So I will see you next week. Thank you so much.